graph y equals -2 times x minus 1 times x minus 5. If you'll notice, this equation is in intercept form, which is a times x minus p, x minus q. So the first thing we want to identify is our x-intercepts, which are the points p0 and q0. So p is going to equal to, if we look inside the first parentheses, we see a -1. We have to think opposite. That's really a +1. So p is 1, and q is going to be, inside parentheses, we have a -5. We think opposite, +5. So I'm going to plot the points p0, which would be 1, 0, and the point 5, 0. These are your x-intercepts. We know the axis of symmetry is halfway between these two, so we can use our formula for the axis of symmetry, which is x equals p plus q divided by 2. If we do that, we've got 1 plus 5 divided by 2. So 1 plus 5 is 6. 6 divided by 2 gives me 3. So if I go to x equals 3, that's 1, 2, 3, I'm going to have my axis of symmetry. Another way you could do it is just count, okay, how many spaces are between the x-intercepts? 1, 2, 3, 4. So cut that in half and go over 2, and you're at the axis of symmetry in either direction. We need to find the vertex. Remember that the vertex is a point. It is always on the axis of symmetry, and our axis of symmetry is at x equals 3. So our x-coordinate of the vertex will be 3. So we just need to plug in 3 into our original equation for x, and we'll calculate its y value. So I've got -2 times 3 minus 1, that's in parentheses, times 3 minus 5, which is also in parentheses. So that gives me -2 times 2 times -2. And that's going to be 2 times 2 is 4 times 2 is 8. And I just said a negative times a negative is positive, so they're going to all be positive, so that gives me 8. So I'm going to plot the point 3, 8. So I've got my vertex, I've got my two x-intercepts. I'm going to connect these 2 points. And I've got my parabola. There's the graph.